my name is Walter Unglob, and this is how to figure out the period given with a trig graph. So here I have my yt plane, where y is a function of time, and let's say I have a trigonometric graph, in this case a sinusoid, where the amplitude is equal to a. So I have positive a here and negative a here. I notice that the sine is 0 at pi, but then returns to 0 at 2 pi. And if I were to continue the t-axis, I would have repetitive behavior. So I can write down a function for this. In this case, it would be a times sine of t. But it turns out that generally I can have a frequency omega t inside of the sinusoid. And if this frequency is higher, then my period will be smaller. So the period then is defined as the change in time over which the signal, or in this case this function, repeats. And so all I would have to do is calculate the period by subtracting from the final time the initial time. So in this case, I would have 2 pi minus 0, which is just equal to 2 pi in whatever units of time my x-axis is in. Generally, however, the angular frequency omega is equal to 2 pi f. This is the equation that relates linear frequency to angular frequency, and the linear frequency is simply 1 over the period. Therefore, whatever number appears in front of the independent variable in the sinusoid is going to be your omega, and that's going to be equal to 2 pi f, or 2 pi divided t. Therefore, the period is going to be equal to 2 pi divided omega. We see that in our simple example, my omega is going to be equal to 1, because there's just a 1 being multiplied to the t. Therefore, for omega is equal to 1, my period is 2 pi, as I confirmed by simply looking at my graph of a trigonometric function. So this is how you would find the period for a given trigonometric function that exhibits periodic behavior. My name is Walter Unglob, and this is how to figure out the period given with a trig graph.